English with Astronomy, Episode 6.
Yes, let's continue.
We've just figured out that the reason all the stars sweep across the sky together is that our planet is rotating. We don't feel that rotation ourselves, or do we?
Maybe not in everyday life, but we can prove it experimentally. And that's exactly what my next story is about.
Okay, I won't hold you up. Go ahead.
The next episode is called How We Know the Earth Rotates. Long ago, people thought that the Earth was flat, like a pancake, and that it rested on whales, elephants, or turtles. It is impossible to notice the motion of the Earth while standing on its surface. A human is too small compared with our enormous planet. As science developed, people's ideas about the Earth changed. Now we know that the Earth takes part in several motions at the same time. Today, scientists can confirm the Earth's rotation on its axis with a number of experiments. The most famous one was carried out in the middle of the 19th century by the French physicist Léon Foucault. The setup was a heavy pendulum on a long cable. The longer the cable, the better the experiment worked. That is why such a pendulum is usually installed in tall cathedrals, museums, and observatories. If the pendulum is pulled away from its resting position and released, it will swing in a single plane. This is a law of physics. This plane passes through the starting point, from which the bob was displaced, and the equilibrium position. If the Earth did not rotate, then relative to the Earth, the plane of the pendulum's swing would remain constant. In reality, the experiment shows that the plane in which the pendulum swings slowly turns by a certain angle relative to the Earth. This turning is explained by the fact that the Earth rotates around its axis. In Foucault's experiment, during the pendulum's motion, the Earth turns beneath it. An observer on the Earth's surface does not feel this rotation, so it seems to them that the plane of the pendulum's swing is the thing that turns. The rotation of the globe around its axis is called the daily rotation. The rotation is from west to east. Its period is 24 hours, which means in 24 hours our planet makes one full turn. If the Earth did not rotate, the side facing the sun would always have daytime, and the opposite side would always be dark. However, we see that morning is followed by day, day by evening, and evening by night. Morning comes first in China, then in Europe, and later in America. We also do not feel the Earth's motion around the sun, but we do notice the change of the seasons and the changing length of daylight and night. The Earth makes a full orbit around the sun in a little more than 365 days. This period of time is called a year. Besides these two motions, our planet also takes part in several others, because together with the sun and the other planets, it moves relative to the Milky Way. The Milky Way moves relative to other galaxies. In general, it seems that there is nothing completely still or unchanging in the universe.
A quick comment on the text. The classic pendulum experiment was done in Europe, so the rotation was noticeable. At the equator, we wouldn't see the pendulum's plane turn.
Right, and at either pole, the effect would be strongest and easiest to notice.
Did you know they actually repeated that experiment at the South Pole not long ago?
Oh, really? I didn't know. How did it go?
They confirmed, once again, that Earth does rotate. Maybe we'll cover that in a future episode. For now, it's question time.
I'd love to hear more about the polar experiment later. For now, go ahead with your questions.
Question 1. Which experiment does the text describe? Question 2. Where is the pendulum usually installed, and why? Question 3. In which direction does Earth complete its daily rotation, and what is its period? Question 4. Which motion of Earth explains the seasons, and how long does it take?
Now let's hear your recap of the text. Are you ready?
Yes. Here we go. Long ago, many people pictured Earth as a flat disk resting on animals, and from the ground, we can't directly feel the planet's motion. As science advanced, our view changed, and we learned Earth participates in several motions at once. A famous proof of Earth's spin is Foucault's pendulum, first demonstrated in the mid-19th century by Léon Foucault. It's a heavy bob on a very long cable, often hung in tall cathedrals or museums, so the effect is clearer. Left to swing, the pendulum moves in a single plane, yet relative to Earth, that plane slowly turns. What's really happening is that Earth rotates beneath the pendulum, creating the appearance that the swing plane is rotating. This daily rotation is from west to east, and one full turn takes about 24 hours. If Earth didn't spin, the sun-facing side would be in perpetual day and the far side in endless night. But instead, we experience morning, day, evening, and night. Dawn arrives earlier in places like China, then in Europe, and later in America because the planet rotates eastward. We also don't feel Earth's orbital motion around the sun, but we do notice the seasons and changing day length. One full orbit takes a little more than 365 days. That's a year. Beyond these, Earth moves with the sun and planets within the Milky Way, and the Milky Way itself moves among other galaxies. So on every scale, nothing in the universe is perfectly still. And a quick reminder, earlier today we talked about what the sky is and why it seems to rotate.
In the next episodes, we'll meet our galaxy, talk about timekeeping, and introduce some useful astronomy terms.
Great! That's a wrap for today. See you soon.
Bye, everyone.